Okay. Um. Somehow, despite having a pretty good score in homework. So you people, some people still not using the process, okay? So we want to make sure we understand the process, because the next assignment, you're gonna have to do this with 3 equations and 3 of them. So what's the logic of this? If you add these, you're not going to eliminate X. As they are. If you add these as they are, you're not going to eliminate Y. Okay. What we're going to have to do is we're going to have to take the first equation and multiply it by 2. And the second equation, multiply it by -3. What does that accomplish? 2 times 3 is 6. So we'll multiply 2 by this equation, we're going to get a 6. We'll multiply -3 by this equation, it's going to give us a -6x. We can always do this. Okay, we can multiply this equation by this number, and this equation by this number. Take one off negative if necessary, and we're going to be able to eliminate X. Alternatively, we could have multiplied this equation by 4 and this one by 3, and we'd got a 12y and a -12y. The y's would have matched up. We could do either. So I'm choosing to pick on the X first because there's no easy way. There's nothing easier about picking on the Y, except it's what we have the negative built into one of the coefficients. Okay, well, if we do this, we end up with 6x. Now, you can't just multiply this by 2 and not multiply this by 2 and this by 2. If you do multiply just one of these terms by 2, the equation is no longer equivalent to the one we started with. We have to understand that we can multiply both sides of the equation by the same number without changing its solutions. So we do this, and we get 6x plus 6y equals 44, and -6x plus 12y equals 12. Now you need to imitate the way you see me write these out, because I'm saying a lot of things that don't follow the same procedure we gave you last time, and it's identical to the procedure Open Math is giving. Okay, you need to have all the details of that procedure down and do problems until it makes sense to you. So whatever is going on, and I also emphasize, bring your written work in, so I can see what you're doing when you do your homework. But somehow it's not transferred. In some cases, so some people do just fine with it, but there's something about the way people are approaching Open Math that I don't understand. I need to understand that. But be more helpful. Okay, so please bring your work with you. And also, I keep urging, don't do every problem by imitating a video. Every problem, after a while, you need to be able to solve them on your own, so they come into class and solve them. Okay. Okay, anyhow, this is what we have. We add these two, and we get 6x -6x gives us 0. We have 18y equals 46. Now we can solve this for y. Plus 36 over 18, and that's 2. Now we know the y equals 2. We substitute out M for Y in either equation. So I'm gonna plug 2 in for Y here. It's gonna come down here and give me. This is obviously Y is replaced by 2. If you look up here, look down here, this is what we have. Then we solve for X. And we get. And then check. We plug 2 in for X and 2 for Y. 3 times 2 is 6, 3 times 2 is 6. 6 and 6 is 12, that checks. 2 times 2 is 4. 2 times -4 times 2 is -8, 4 and -8 is just -4, that checks. This also checks with our graph. We sketch a graph, we find that the x-intercept is first, if y equals 0, we're going to get x equals 4. We have a 0.04. If x equals 0, y equals 4, so we also have upside. Let's do that. It's 4, 0. This point is 0.04. There's this point is 0.04. There's our graph of the first equation, 3x plus 3y is 12. Second equation, if y is 0, x is -2. So we have -2, 0. And if x is 0, y is 1. We have this graph. And now we try to estimate the coordinates of this point. This one comes down to here. Across to here. I'm going to estimate that this is 2.1, 2.3. Well, I know that it should be 2, 2. If I did my graph first and got an estimate of 2.1, 2.3, that's pretty close. So that the graph is consistent with the equation. Consistent meaning not exactly the same, but not so different that we have a problem because the graph is hand sketched. So this whole process is one we did in class last week. I recommend that you follow this process. If there's a different process you see in open math that you like better, follow that process, but write out every detail when you do the problems. If you're skipping details, you're not reinforcing the ideas. Remember, your goal is to be prepared to come into class to solve a problem in any ways you have in open math, okay? And you're gonna really need to do that. We do 3 equations and 3 unknowns, which is the next thing. Okay, so I'm going to write down the equation, 3 equations and 3 unknowns, and let's see how we can do with that. Now, the problem with 3 equations and 3 unknowns is if you got 2 unknowns, you can do that with an x and a y axis. You got 3 unknowns, you're in 3 dimensions. You got like x here, y here, and z here. So it gets harder to visualize. And we're not even going to try to visualize it. Comes in many way portions. But what you get in 3 dimensions is each equation gives you a plane. I have a plane in this direction, then a plane in this direction, then a plane in this direction. Do they intersect? Okay. Is there a point where they all intersect? Well, if you just make up random coefficients, it's very likely that they will intersect. Sometimes they don't, and we'll talk about that later, but that's kind of context that we're looking at. So I'm gonna write down 3 equations. You're not gonna be able to graph it. Because again, they're in 3 dimensions, it's harder to graph in 3 dimensions. There's your equation. What we're going to do is we're going to eliminate x in the second and third equation. So what multiple of the first equation we could add to the second in order to eliminate x? So most of the first equation could be added to the second to eliminate x. Okay, well, the answer, here's the first equation, here's the second equation. Now, I've got plain old x there, I've got 2x here, right? So if I multiply the first equation by -2, I'm gonna have -2x and 2x, and x is gonna go away. Let's do that. Okay. -2 times the first equation, you're gonna multiply x by -2. And multiply y by -2. And multiply z by -2. And multiply the 3 by the -2. Everybody. Doing that? Write it down. Okay. And then the second equation. -2 times our original first equation plus the second, which is what? Go ahead and add those up. Okay. So we have -2x and 2x. Those are equal and opposite, they give us 0. We have -2y and -3y. We got -2 something, -3 something, that's -5. Oh, negative 2y, negative 3y is negative 5y. Negative 2z and 4z is plus 2z. And negative 6 and 2 is negative 4. So that gives us this equation. And we don't have to divide the zeros by. So now we've got an equation in just two variables. Now, can we do the same thing? From the first and third equations. Okay. We want to eliminate x from our first and third equations. Then we're going to have to multiply the first equation by negative 5. We multiply this first equation by negative 5, this is what we get. Now if we write down our third equation, we have 5f plus 2y minus 3z equals 4. So what do we get when we add these two equations? I said that before you wrote down that second one, but I saw you to write it down, so I assume you wrote that down. Okay. Okay, so. We're good here. We have these two equations, the x's go away, get a 0 there. We're going to have minus 3y. We're going to have minus 8z. We're going to have minus 11. Right? Now we have two equations with the same two variables, y and z. Solve them using the methods. Or rational side. So we've got this. It's a little messed up, but apparently it's what it is. Okay, looks like I've been across the halls. From years of my childhood to get into the real ancient history, guys. So. I'll make sure there's not something wrong because. Well, I did. Okay. No. Okay, well, it is what it is. We can solve these equations. Okay, I'm not gonna go through any more details on this one. I'm just gonna say that we have a system of two equations using the same methods that we used previously. We can solve for y and z. And then we plug those y and z values back into the first equation. It doesn't have to be the first equation. It could be any one of these equations. If we got values for y and z that we get solving these, we can then solve that equation for x. And we have our entire solution. So what it comes down to is when you have three equations and three unknowns, you pick on a variable to eliminate. In this case, we went ahead and picked on x. But at least one person went ahead and noticed that he could pretty easily eliminate y between two of these equations. And so we could have eliminated y from both the, from, let's say, these two equations or these two equations. And gotten two equations that would have x and z. Okay. The point is, you can pick any one of these three variables and eliminate it from some pair of from two pairs of equations. Okay. You get an equation of two variables, you solve it, you plug that solution back in and find the third variable. Okay. So write down another system and ask you to do as much as you can. Just to figure out what variable you want to eliminate. Pick two equations and eliminate the variable between those two equations. Okay, now I'm going to need to move on with this. Having some trouble with this, but make sure we're very, very clear about what we're allowed to do and what we're not. So I'm going to pick the easy variable to eliminate, which is z. Okay. Now, some people chose to eliminate x. That isn't hard. You multiply the first equation by 2, and the second by -3. That's the limit. And then you can choose these two equations. Just multiply this equation by -2, and you match up the x and you get a second. But it would work just fine. I'm going to do. So I'm going to take the first equation and add it to the third equation. That's going to give me two equations, and I pick them because I got a negative z and a positive z. So the z's are going to eliminate. We'll end up with 18 over here, so an x here, and then a y here. in their house. Then I'm gonna do twice the first equation added to the second equation. Because if I do twice that negative z, I get negative 2z, which will match up with this. So do 2 times the first equation plus the second. That's going to give me 6x plus 10y minus 2z equals 110. That was the first equation. And the second equation is 2x minus 3y plus 2z equals 1. 6x and 2x gives me that. 10y and negative 3y gives me 7y. And 14 and 1 gives me 15. I have this equation. This equation. I'm going to go ahead and solve these. Okay. And it's not divided. Okay. Now I'm going to have to use some fairly big numbers. I'm going to have to multiply this equation like by 8 and this one by 7, one of those by negative. Okay. So I'm going to do -7, -8. That's the first equation, going to give me negative 56x minus 88y equals negative 144. And then I'm going to do 7 times the second equation, which is going to give me 56x plus 49y equals 105. So, well, this gives me negative 39, negative 39y equals negative 39, so y equals 1. Okay. Then I'm going to plug that y equals 1. It's an equal equation. And that's going to give me 7x plus 11 times 1 equals 18, which means it's going to be 7x plus 11 equals 18. 7x equals 7, and that's what equals 1. Okay. Now, I take my y and my x and plug into any one of the first 3 equations. And so I'm going to plug quickly. First equation. Plug in my x and my y values in them. Give me the equation. Three times 1, 5 times 1, minus z equals 7. Eight minus z equals 7. And we do the remaining steps. We find that z equals 1. So now we know the solution of our system. Now, we could have chosen to eliminate a different variable. Nothing wrong with eliminating X, it would be difficult. Okay. Nothing wrong with eliminating Y. That would have been difficult. What you want to look at is all three variables and see which one is the easiest to eliminate. You know, there's much more to the assignment. But we needed to at least get this idea about it. It's possible when you eliminate one variable that you that another variable just happens to match up and gives them that data. You might eliminate two variables at the same time, and that gets the interpretation of that. Well, we'll have to talk about that next time you're going to see it in your assignment. Okay. Okay, question came up. Somebody's been paying good attention. Can you have a situation where you have no solution, where you have an intermediate solution? Okay, go back to lines. You have two lines, don't have the same slope, they have to intersect. If they have the same slope, they're parallel. Now, if they're parallel, either they never intersect or they're the same. Okay. So you can have infinitely many solutions, because what you're looking for is a set of points that satisfy both equations. If you have parallel lines that are right on top of each other, meaning they're the same line, then every point on that line is a solution. If you have parallel lines that don't intersect, there's no point that lies on both lines. If they're not parallel, they will intersect, and it'll be exactly one point where they match. Okay. If you have a three-dimensional equation, you have planes. Now, if you have two planes, they intersect. Take two panes of glass and intersect. They'll intersect along a line. Okay. Now, if you have a third plane, if it's not parallel to one of the first two, it's going to intersect that line, and there's your point. Okay, but if it happens to be parallel to one of the other two, well, if two of the planes are parallel and not intersecting, then there's not going to be any point where all three lines meet, or all three planes meet. Now, if one of the planes is on top of one of the others, then you could have a whole line of intersection between those common planes and a third plane. All right. So there are all kinds of possibilities. And we're not talking at this point about those possibilities. We're having a lot of difficulty with just getting the process started. So we just have to make the choice that I'm talking about that in this one. We'll talk about that in pre-calculus. I take it back. This is pre-calculus. So we're going to talk about it, but we can't talk about it today. We'll talk about it next time. Okay. And next time we got to get into matrices and deal with that. So try to do very well in this assignment. Try to work it out in detail and write everything out. Show me what you're writing out when you come in.